Okay, so time's up for answering the quiz one. Okay, so stop answering your quiz. You can start with the submission process. Okay, so I give you 10 minutes to submit to the Google Classroom. After 4:45, I consider that it is a late submission. After 4:45. So do it now for the submission. And then you can off your camera. Thank you. But wait for the class, eh? Do not leave this meeting.
Adam.
Okay, so we shall start with the class. Um, please make sure that you click on turn in when you upload your answer. I think Edwin, you didn't click on turn in when you upload your answers. So it's still assign, not complete, submit yet.
Now, Amelia?
I think that you didn't click on turn in when you upload your your answer. Okay, already. Okay, thank you.
Okay.
So we start the class. Already take note who still do not submit. Okay. Okay, so before we start with the class, next week supposed to be quiz 2, okay, which is 2.2. But because of some of you still not from this section only, from my another section still didn't have the statistical table. This one, okay, because we are going to use for the chapter 2 onward. So I will postpone the quiz 2 on week 5. Okay. So quiz 2, take note, it will be on week 5. For now, it will be on Wednesday, like today. Okay. So quiz 2 on week 5. Okay. So we back to the lesson. So today I will continue with the 1.4, the box plot, outlier and box plot. Okay. Okay, so one of your friend asked whether there is any discussion on the quiz. So far, I didn't plan for that, but I will provide you with the answer scheme. Then I will upload in Google Classroom later the answer scheme of your quiz. If anything, you can always ask me later, discuss with me later. Okay, but so far I didn't plan to what we call discuss on the quiz, but test later inshallah. Okay, I will discuss the test after we do the test. Okay. Okay, so we start with the 1.4, the exploratory data analysis, the outlier and also the box plot. Okay, so as I mentioned last week, okay, so before this we just suspect that the value which is isolate from the rest of the data set, it is an outlier. But now in 1.4, we will discuss how to confirm that it is really outlier or not. Okay. So I will discuss through the exercise that I asked you to do on the box plot. Okay. We go straight to that exercise. So exercise 1.4, 1.2. Okay, number 1 here is a single box plot because of you have one set of data on each question, means that you are dealing with the single box plot on the same as on and as this one. Okay, so similar to the question B. So when we have single box plot, so this is the answer lah. Okay, your box plot should be in this form. Okay, so when we have single box plot on an axis, okay, so not the only, okay, how we interpret, the first thing is we discuss the shape of the box plot, okay, and also you can discuss the average, similar, but not comparing lah. But when we have more than one box plot, then we tend to compare, okay, the data set. Okay, so in this case, we have the horizontal box plot. Okay, we use x-axis as our axis. Okay, but you can always have the vertical box plot. So vertical box plot, we use the y-axis as our axis. Okay, so make sure that when you plot the box plot, you have proper axis so that it will be easier to determine the shape later. Okay, if not, it will be difficult. Okay, so we have missing information here. Okay, you need to label your box plot. Okay, so label box plot, label the value. Okay, so box plot, okay, before that, okay, box plot is about 5 number summaries. Okay, So those five, we have the minimum value of your data set. We have the Q1, and then we have the Q2 or median, okay? And we have the Q3, and then we have the maximum value of the data set, okay? And we plot the outlier if exists, okay? Other than that, we don't plot in our box plot, okay? So usually students get confused with the lower limit and upper limit that we calculate when we need to determine whether there is an outlier or not in our data set. Okay, student tends to plot the lower and upper limit. Okay, so lower limit and upper limit that we calculate to determine whether there's an outlier or not, only for that. Okay, we do not plot in our box plot. So box plot, it is about 5 number summaries just now, and also the outlier if exists. Okay. So after you draw your box plot here, we need to label the value that you plot. Okay, so here we have the minimum value. Okay, we have the Q1, Q2 or the median, and then we have the Q3, and here is a max value. Okay, if you have the outlier, for example, the second question here, this is the outlier. So we need to label also. This is outlier. So that reader know lah. This is the outlier. Okay. Okay. We go to the number 2. Okay, hopefully they already done this one. Okay, so calculation and also how to draw the box plot. You can always watch the video until you understand how to draw the box plot. Okay, so drawing part is easy. What I want to highlight here, how to interpret on your box plot. What kind of information that we can get based on the box plot. Okay, so I will not touch on the how to draw the box plot. You can always watch the video. Okay, I'm going to discuss what we can discuss based on the box plot. Okay, so we need to compare the distribution using box plot. Okay, so clear here why you need to draw the box plot, because we have the word here lah. Okay, using box plot. Okay, compare the distribution. Distribution that we meant here, it is a shape of your distribution. Okay, shape. Okay, so based on the box plot, we can get 3 different shapes only, like measure of central tendency. Okay, so similar to the measure of central tendency, we can have 3 different shapes only. Okay, they are left skewed, right skewed, or symmetric. Okay, you can get either right skewed, left skewed, or symmetric. Okay, so similar to the measure of central tendency. Okay, when we have the histogram, you can get 8 different shape. Okay, so if you try to compare when you do your assignment later, okay, when you go to the part of compare the measure of central tendency, you can get the shape from there. And also when you go to the, I think the last 3 questions about box plot, okay, also you have to determine the shape. If we get different shape, don't panic lah, because sometimes similar to the histogram, sometimes you will get different shape than histogram. Okay, similar data set, but box plot you get different than histogram. Okay, it is okay to have different shape, because the histogram itself, okay, the shape influenced by the bin that you choose for the histogram. Okay, the bin that you choose for the histogram, the value that you use, the range of data that you choose. So the shape could be different. It is okay to have different shape. Okay. Okay. And then we need to comment on the flexibility of the spring. Okay. So this is a general question. Just comment on the flexibility of the spring. Okay. Like what we discussed in measure of variation, if you still remember, okay, it is about we comment on the lifetime of the battery. Okay, so the question just which one which one is a better battery? Okay, so it is a general question. We do not use special terms. Okay, special terms for the verbability, for example. So it can be average or verbability. You can use either average value or the verbability. So similar to here. Okay, it just flexibility of the spring. We do not use special terms for verbability, for example, consistent, okay, precise. Okay, then to comment on the flexibility, you can comment in terms of average and you can comment in terms of verbability. Okay, so these are three things or three measures that we discussed for the box plot: shape, average, and also verbability. But not always we have to discuss all. Okay, depends on the question. But because of here is a general question, then you can discuss average or you can discuss the verbability. Now I will show both. Okay, if we use special terms, for example, which box plot is more consistent? Okay, so consistent is a special term for the durability. So you have to go to durability. We cannot use our average to compare that. We cannot use the average to determine which one is more consistent. Okay, so depends on the question. Okay, so first we draw the draw the box plot. Okay, so this is the box plot that you should get lah. Okay, so when we compare data sets, okay, we have more than one data. Okay, you have to draw your box plot on the same axis. Okay, if you compare 3 data, you compare 4 data, 2 and above, then all the box plots must be on the same axis. Similar for your assignment, you have 4 set of data, so those 4 box plot must be on the same axis because we are comparing the box plot, so they cannot be on separated axis. Okay, so you can have the horizontal, here is a horizontal box plot, or you can have the vertical box plot, it's up to you. Okay, when we have more than one box plot, then you have to label lah. Okay, that box plot for which data. So here the first one for the company A and second one for the company B. So that reader know. Okay, and then as a previous one, you have to label. This is the outlier. Okay, you have the mean, Q1, Q2, Q3, and max. Okay, so similar to the second one. Okay, so when you have the outlier, okay, it is compulsory to draw your outlier parallel to its box plot, so that we know that this outlier belong to this data, this set of data, not to this data. Okay, if you plot this outlier to here, then we read this outlier belong to this data set. Okay, so that's why the outlier must be parallel to its box plot, means that to its group of data lah. Okay, so after you draw the box plot, we go to answering the question lah. So the first one, distribution. Distribution is the shape. Okay, the shape of your box plot. If you have any question, you can interrupt me. Okay, so first, distribution. Which is the shape. Okay, so what is the variable of this data? Anyone? Variable of this data? The data is about what? Anyone? Are you still here?
Still drops.
Okay, so the data is about what?
Flexibility.
Flexibility of the spring. Okay, so shape of the box plot. Okay, so how to determine the shape of the box plot? It is based on the location of median or location of the Q2 here. Okay, so if your Q2 close to the Q3, like the company A here, then it will be, apa dia? What shape that we have here?
Left skew.
Left skewed. Okay, if Q2 here, okay, so for the company B, Q2 close to the Q1, then we have what shape?
Right skew.
Right skewed. Okay, so left skewed for the company A, right skewed for the company B. Okay, let's say that we have, for example, this box plot and the Q2 located at the middle of this box. Okay, when we have Q2 located at the middle, then the rule is we need to consider this line and this line. Okay, if we have similar length, then it is symmetric distribution. Okay, so now we have here and right skewed. Okay, okay, so what we can say here, most of the data located at the right tail, okay, and here most of the data located at the left tail. Okay, and then we go to the comment on the flexibility of the spring, just to comment. Okay, so you can, this is a general question, flexibility of the spring, then we can comment based on the average and also the probability. Okay. Okay. Flexibility of spring. Okay, so first you can comment on the average, and second we comment on the probability. Okay, but okay, so now we have average and probability. So what value that we need to use to discuss the average and also probability? Okay, for the case box plot, for the average we always use median or Q2 value. Okay, for the probability here, we always use IQR, interquantile range. Okay, doesn't matter the distribution that you have is a skewed or symmetric. Okay, because box plot here is just what we call it just based on the visualization, so it is not really accurate. Okay, the shape that we have. Okay, so that's why for the box plot, we don't, doesn't matter that we have skewed or we have symmetric distribution. You need to use median for the average and we need to use IQR for the probability. Okay. So we go to the average first. Okay. So you have to comment, okay, the flexibility of the spring based on the average. So we have Q2A for the company A, 8.25. And then we have Q2 for the company B, 10.15. So first interpretation that you can write, or first discussion that you can write, okay, based on the average, you can compare, okay, these two values. Okay, so we have Q2A less than Q2B. What we can conclude from here? Which one is more flexible? Which one is more flexible? So Q2A less than Q2B. So average value of A less than average value of B. So which one is more flexible?
B.
It is B. Okay, because it is based on the average. So B is more flexible. Okay, one of the discussion that you can write based on, or one of the comment that you can write based on the average. Okay, the second comment that you can write based on the average. Okay, so for the spring A, so we can write that the flexibility of the 50% of the spring A is more than 8.25 nm. Okay, is it correct if we change more than here with the less than? Is it correct or not? If we said that 50% less than 8.25.
Correct.
It is correct, okay, because median is about middle of the data set. Okay, median is about middle of the data set. So median, then we have 50% here, then we have 50% here. So it is correct to say that 50% more than 8.25 and another 50% less than 8.25. Okay, so similar to the spring B lah. You can write similar thing for the spring B. So the flexible of the 50% of the spring B is more than 8.15 or is less than 8.15. Similar. Okay, so this is how we comment on the average for the box plot. Any questions so far? Okay. Okay, the rest of you please respond. Do not let only Tan Yong Hao respond. If not, I will just have class with him. Okay, if I ask something, please participate with this class. If not, we can dismiss this class and I can have a class with the Tan only. Okay? So be participate with the class. Okay, so then we have the probability. Okay, so how we comment on durability? So for the box plot, we use IQR. Okay, so find the IQR of A and then IQR of the B. Okay, so IQR of the A, we have
1.5.
1.5. IQR for the B,
1.2.
1.2. So it is, so it is Q3 minus Q1. Okay. So based on the IQR here, what you can write first, similar to the average, we can compare. Okay, these two flexibility of the spring. Okay, so IQR. So which one is a better one? It's more flexible. IQR of A greater than IQR of B. So which one is more flexible?
IQRB.
It is?
IQRB.
It is a
B.
spring B, not the IQRB. This is spring B. Okay. So what you can write here, the flexibility. Okay, so we can write that flexibility of the spring B is more consistent than spring B is more flexible. Okay, or you can write about, or you can comment about, okay, IQR here, it is between Q3 and Q1. Okay, so the Q3 and Q1 here, it is about 50% of your data set. Okay, if you go through the measure of position again, okay, the position of the Q1 and Q3, it is about 50% of the data set. So you can comment on that lah. Okay, for example, string A. Okay, so Q1 is 7.3 and Q3 is 8.8. Okay, so you can write that the of 50% of also correct. Huh? We talk about 50% of the data, okay, based on the IQR, also correct. Okay, or you can just compare. But usually for durability, we go to the comparing the IQR value and then discuss which one is more consistent or which one is more precise. Okay, any questions so far?
No, doctor.
Okay, so next is a normal probability plot. Okay, this one I leave it to you. Okay, but in general, okay, normal probability plot is a easiest plot or the easiest way to do in order to check whether the data that we have here is a normal or not. Okay, so normal probability plot here, it is in your part 2 of your assignment. Okay, so why we need to check for the normality of the data? Okay, for your information, okay, all the inferential method in this course, starting from confidence interval, hypothesis testing, the ANOVA letter, anti-chapter 6, they are for the normal data only. Okay, so in general, we call them as a parametric method. Okay, if your data is not normal, actually we cannot use the method in this course. Okay, you have to go to the non-parametric method. Okay, so that's why for your assignment, we just want to expose to you lah how to check the data that you collect for the part 1, it is normal or not. Okay, even though it is not normal, you just proceed to the hypothesis testing lah. We just assume that the data that you have here is a normal distribution. Okay, so you just do the plotting here. Okay, you can watch the video. If the sample point, if your data value here, okay, lies in on a straight line, then it is approximately normal distribution. Your data is approximately normal distribution. If deviate from the straight line, most of the data deviate from the straight line, then your data is not normal distribution lah. Okay, if the most of data on a straight line, then it is approximately normal distribution. It is important to write the approximately because it is not really perfect yet. Okay, perfect means that your data mu is 0 and we have 1 for the variance. That's a perfect normal distribution. But we don't, it is really impossible to get that lah. That's why we use the approximately normal distribution here. Okay. So that's what you need to do for your assignment. Okay, so this is just for your information. Okay, so plotting just based on the visualization. Sometimes student A said similar plotting, similar data set, but we can have different answers. Student A said normal, but student B, based on his or her eyes, it is not normal. So to confirm that, we go to the testing. Okay, so we have a few that what we call well-known, used by the researcher. Okay, you have the Kolmogorov here, you have the Anderson, Darling, and Shapiro-Witt task. Okay, you can use the software to use to conduct that testing lah. Okay, but for us, it is only plotting. Okay, so you can play around with this exercise using your Excel. Okay, any question? So that's all for the chapter 1. Okay. So I would like to proceed to the chapter 2. Just maybe we discuss a few things in chapter 2 and then I think next class we continue with the exercise that I asked you to do. Okay. Okay. Any questions so far?
No.
No, madam.
Okay.
No.
We go to the chapter 2. Okay. So chapter 2 onward, it is inferential statistic lah that we discussed in chapter 1. Okay. So we use inferential statistic to make conclusion, to estimate about the population value or population characteristic by using sample data. Okay. So what we do in chapter 2, okay. The sampling distribution is not here already. Okay. We have in the module but in the syllabus already take out. Okay, so only confidence interval. Okay, take note. Again, so what we do in confidence interval in general, we construct the range of value in order to estimate the value of the population. Okay, so we have range of value and then we assume that the population value lies within that range, but we never know which value represent the true value. We just estimate, we just assume that the population value that we need lies within that range. So we provide a range. That's confidence interval. Okay. So what you have in chapter 1, you calculate mean, you calculate sample mean, you calculate sample variance. That is a point estimate for the true value. Okay. So chapter 1, the confidence interval, it interval estimate. Okay. So we have about 7 subtopic. Okay. So for this applied statistic course, we have 3 common value that we calculate for our data. Okay, we have mean, we have the proportion, and also the variance or standard deviation. Okay, that's why here we try to estimate the population mean, the population proportion, and also the population variance and population standard deviation. Okay. Okay, so this is the term that we have. Okay, we use estimator to estimate the population value. So the whole process, okay, confidence interval, the whole process to find the confidence interval, that one is a estimation process. Okay, so estimation is the process to use estimator to estimate the population value. Okay. I'm not going to discuss the theory here because you can watch the video, that video made by me. So I think already talked a lot in that video. Okay, so we go to the 2.2. Okay, confidence interval for the population mean. So today I just want to discuss the formula and also how to find the distribution value, the Z and T. Okay, that's one. You need to have this book, this statistical table, because I will show to you where you can find the formula and where you can find the critical value. Okay, that's why I have to postpone the quiz 2 also lah. Okay, so try to have this statistical table as soon as possible. Okay, it is not necessary to use this version. You can always use the old version. Okay, this one also okay. This is the first version that we have. Can you see? Okay, this is the first version of the statistical table. The second version is the orange one. Okay, and this is the third version. So you can use either one. Okay, just what we call, for the new version here, we have additional formula, but still based on the old version, we have general formula that you can use to get the additional formula from here. Okay. Okay. So confidence interval for the population mean. Okay, estimate the confidence interval for the population mean when population variance is known or unknown, and then estimate the sample size by using concept of confidence interval for the population mean. So we can use the concept of confidence interval for population mean to find or to estimate the sample size. Okay. So population variance is known or unknown. Okay, known or unknown here means that in that question you have population variance or you have sample variance. Okay, that's why I said in chapter 1, okay, what we call population and sample are very important when we go to the chapter 2 and 3 especially. Okay, you really need to distinguish, you really need to know how to distinguish the value given is a population value or the value given is a sample value. Okay, because it will be influenced which formula that we need to use. Okay. Okay, we go to the formula. Okay. So confidence interval for the population mean. Okay, so it will be mentioned in your question that we need you to construct the confidence interval. Clear? Kat sana, you have to construct confidence interval. If there is no word construct confidence interval, then you don't have to construct confidence interval. Okay, so it is clear that construct confidence interval, then you have to construct the confidence interval. Okay, for the population mean, it will be mentioned somewhere that the parameter that you need to estimate is a mu. Okay, maybe it will be crystal clear that you have to construct confidence interval for the population mean, or it will be implicit somewhere. Okay, that parameter that you are going to use here, parameter that you are going to estimate is a mean. Okay, so that's why in the video I said before you jump to the solution, when you do the exercise, before you jump to the solution, it is very important to extract the information first. Okay, so that we know what estimator given, okay, the variable that we use, so that we can determine, okay, what parameter that we need to estimate, okay, which formula that we need to use. Okay, so we have these three formula for the confidence interval of the population mean. Okay, so the first condition, you need to know whether sigma is known or unknown. Sigma is known means that we have sigma or sigma square in that question. There is no S. Okay, but whenever you have sigma or sigma square in the question, we use the sigma. Okay, even though there is a S in that question, we go to the sigma because sigma is a, kenapa? Anyone? Let's say that in that question, we have both. We have sigma and also we have the S. But why we go to the sigma? Why? Anyone? If you have sigma, then ignore the S. Okay?
Because there is notation for population.
Yeah, sigma is a notation for the population, but it is not the reason why we use sigma. Okay. Okay, so I think there is an example here. Okay, let me see. Okay, here. Okay, you can read after this. Okay, we have population standard deviation 7 kg, means that this is your sigma. Okay, a random sample of 9 packet. So we have random sample. This is the data of sample. So you have sample data. So whenever you have sample data, then you can get your S bar from here and you can get your S from here. So we have sigma, we have S, but here we go to the known. We use formula with the sigma. Okay, why? Okay, because sigma is a true value, S is an approximate value. So why we go to the approximate if we have the true value? Okay, so whenever you have sigma, it doesn't matter there's an S or not in that question, we use the sigma because sigma is a true value to use and S is an approximate value. That's the reason why. Okay. Okay, so when sigma is known, then we means that we have sigma or sigma square in that question. So we use this formula. The first formula here, okay, formula with the sigma and also Z distribution. Okay. If unknown, unknown means that there is a S or S square in that question. There is no sigma in that question. Then we use a second condition here, sigma square is unknown. Okay, if unknown, then you need to identify. You have larger sample or small sample. Larger sample means that n greater than 30 and small sample means that n less than 30. Okay, so if greater than 30, then you have formula with the Z and also S. Why S here? Because there is no sigma. So it is for the unknown. N less than 30, formula with the S but T. For the small sample, we use T distribution. Okay. If you already have your statistical table in page 5, okay, you can refer to your statistical table if you already have this one. Okay. So page 5 here, you have these three formula. Okay. So first column, they are for the confidence interval. And the second column, they are for the hypothesis testing, chapter 3. First column, chapter 2. Second column, chapter 3. Okay, do not mix the formula. Okay, but the formula in the statistical table, it is not complete as the module and also the slide that we have here. Okay, it didn't mention which one for the known, which one for the unknown with the n less than 30 and unknown for the n greater than 30. So you have to identify by your own. Okay, so the keyword is if you have sigma, then automatically it is for the sigma known. Okay, confidence interval for the mu. Mu is a population mean. Okay, and then if you have formula with the S and Z, they are for the largest sample when sigma is unknown. Okay, when you have formula with the T and S, that one for the small sample for the unknown. Okay, so the formula is not complete as the module. So when you do your exercise and tutorial question, practice to use formula in statistical table. Okay, so that you not be panic lah during the assessment. Okay, because during the assessment you only have this table lah to refer. Okay, you cannot, of course, you cannot refer to the module and any notes lah. So the only one is this one. Okay, so practice. Okay, to use the statistical table for the formula. Okay, the rest of the formula we will discuss from time to time lah. Okay. Okay, you can you can interrupt me if you have any question. So we go to the distribution Z and T, how to find the value. Okay, so for the confidence interval of mu, we have Z distribution. Okay, and then we have T distribution. Okay, based on the formula here, what we need is a Z alpha over 2. Alpha over 2 here is a probability value. Okay, for the T distribution, based on the formula, we need T alpha over 2 with no. So for the T distribution, it is a package. Okay, I mean for the T distribution, we do have two value with the T. They are not separate value. So the first value, probability value, alpha divided by 2, and the second value is a nu. So nu here is a degree of freedom. So package for the T distribution, they are not separate value. So the nu here, by formula, it is an n minus 1 for this case. So sample size minus 1. Okay, so the alpha, how to find the alpha? So alpha from the confidence level. Okay, for example, that you have 95% confidence interval. You need to find 95% confidence interval. So this 95%, it is a confidence level. So from here we find the alpha because 1 minus alpha equal to probability here. Okay, the confidence level 0.95. So alpha is a 0.05. Okay. So confidence level is a probability of that represent the range of value that we have. Okay, the range of value, that's confidence interval. Okay, so here we need alpha over 2. So divide the alpha equal to 2. So 0.025. Okay, and here we need T alpha over 2, 0.025. Nu n minus 1. So for example that we have n equal to 10. So we have 9 here. So how to find the value? Okay, if you have your own, please refer. Okay, if not, you can watch the video later lah. Okay, so for the Z distribution, it is on page 36. Okay, page 36 here, table 4. So it doesn't matter what version that you have for the statistical table, Z distribution always table 4. Okay, just find where is your table 4, percentage point of the normal distribution. Z is a normal distribution. Okay. Different version, we might have about one different of the pages. Okay. So you have alternate column here. The first, you have column for the alpha and then the answer that we need, the value that we need, and then repeat with the column of alpha, and then the answer that we need, and until the end. Okay, so the alpha that we need here is a 0.025. Okay, the alpha here, it is our alpha over 2. Okay, 0.025. So find in the column of alpha, where is 0.025? What we have here? Anyone ada kan? 1.9600.
1.9600.
So 1.9600. Okay. Okay, for the T distribution, the next page, 37. Okay, so what we have here, the first column, it is your degree of freedom. And the first row, it is your probability value. So find the combination of 0.025 with the 9. Then you get the value that you need. It is? What is the value? 0.025 with the 9.
3.6897.
Again?
3.6897.
It is different from mine. 0.025. Look at carefully. I think what you just read just now is for 0.0025, isn't it? Our probability value is a 0.025. It should be
2.2622.
2.2622. Okay, so be careful. Okay, the one that you just referred just now, our friend, it is a 0.0025. What we need, 0.025. So 2.2622. Okay. So you can practice on that one. Any question?
No, doctor.
No, madam.
Okay, so we are supposed to discuss the exercise 2.1, but I think we postpone next week. Okay, exercise 2.1 in number 2. Number 2 and also number 4. Okay, you're already tired with the quiz, and then we just postpone to next week. Okay, so you should done your exercise lah. Okay, so for the video, there is a correction on the video. Video 2.2 part 2. Okay, there is a correction. Okay, there is a typo mistake on the answer for question number 3, the one that I calculate for the one-sided. Okay, I will share in the group later. Okay, that correction. Okay. Any question for today?
No, madam.
Okay. So it is okay to postpone next week for this exercise?
Yes.
Okay, madam.
Okay, so again, there is no quiz 2 next week. It will be on week 5. So for me, it's okay lah to postpone this exercise. Okay, we will discuss together with the rest of the subtopic. Because next week, okay. Okay, so that's all for today. Thank you for today. See you next week, inshallah.
Thank you, madam.
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 Okay.
Thank you, madam.